Hi friends. If you are thinking about learning C++, you are in the right place. In this video, we'll cover all the essentials you need to know before starting your C++ journey. C++ is a powerful programming language that emerged in the 1980s, created by Bjarne Stroustrup. It evolved from the earlier programming language called C, which was developed at Bell Labs in the 1970s. Stroustrup wanted to enhance C with features for object-oriented programming, OOP, which allows programmers to organize code into reusable components called objects. By adding these features, C++ became more versatile and suitable for a wider range of applications, from system software to high-level applications. The name C++ reflects its evolutionary nature, with the ++ indicating an increment in the language's capabilities over its predecessor, C. Today, C++ is widely used in industries such as gaming, finance, and system development, making it a valuable skill for programmers to learn. C++ is primarily inspired by the C programming language, from which it inherits much of its syntax and structure. However, it also draws inspiration from other programming languages such as Simula, Ada, and Algol 68. Simula introduced the concept of classes and objects, which heavily influenced the object-oriented features of C++. Ada contributed to C++'s support for strong typing and exception handling. Algol 68 influenced aspects of C++'s syntax and semantics, particularly in its approach to control structures and expressions. These influences helped shape C++ into the versatile and powerful language it is today, capable of supporting both low-level systems programming and high-level application development. C++ is considered a general-purpose programming language because, unlike special-purpose languages that are designed to solve a specific class of problems, example Lisp for AI, SQL for databases, or TeX for typesetting, C++ is designed to handle a wide variety of tasks. It provides the versatility to develop system software, application software, device drivers, and more, across different domains. This broad applicability, along with its performance efficiency, extensive libraries, and support for various programming paradigms, makes C++ suitable for solving a diverse range of problems, rather than being limited to a particular niche. C++ is a compiled language because its code is directly converted into machine code that the processor can execute, resulting in faster and more efficient performance compared to interpreted languages. This compilation process allows for better optimization, giving developers greater control over hardware aspects such as memory management and CPU usage. Although this requires a rebuild step where the program must be manually compiled and rebuilt with each change, the performance benefits and control over system resources make C++ ideal for applications requiring high efficiency and direct hardware interaction. Interpreted languages execute code line by line through an interpreter, which reads and runs the program directly without converting it into machine code beforehand. This allows for greater flexibility and ease of testing and debugging, as changes can be made and immediately executed without the need for a separate compilation step. However, traditionally, interpreted languages were slower than compiled languages because each instruction had to be translated on the fly during execution. With advancements such as just-in-time, JIT, compilation, this performance gap has been reduced. Common examples of interpreted languages include PHP, Ruby, Python, and JavaScript, which are often used for web development, scripting, and rapid application development due to their flexibility and ease of use. And also, C++ is a versatile language that supports multiple programming paradigms. You can use it for OOP with classes and objects, procedural programming with functions, generic programming with templates, and functional programming with features like lambda expressions and higher-order functions. This versatility allows C++ to be used for a wide range of applications, from systems programming to application development. Object-oriented programming, OOP. Object-oriented programming, OOP, is a paradigm centered around the concept of objects, which are instances of classes. These objects encapsulate data and behaviors, methods that operate on the data. OOP promotes principles such as inheritance, where classes can inherit properties and methods from other classes, polymorphism, which allows methods to operate differently based on the object they are called on, and encapsulation, which restricts direct access to some of an object's components. This approach helps in organizing complex programs into manageable and modular pieces, making code more reusable and easier to maintain. Languages like Java, C++, and Python support OOP. Procedural Programming. Procedural programming is a paradigm derived from structured programming, based on the concept of procedure calls. Procedures, also known as routines, subroutines, or functions, are blocks of code that perform a specific task. This paradigm emphasizes a linear top-down approach and a clear sequence of instructions. The focus is on how to perform tasks using a sequence of steps or procedures. It is effective for simpler, straightforward tasks and is foundational for understanding other paradigms. Examples of procedural programming languages include C, Pascal, and BASIC. Generic programming. Generic programming is a paradigm that aims to write algorithms and data structures in a way that they can work with any data type. This is achieved using templates in languages like C++ or generics in languages like Java and C#. The idea is to write code that is not specific to any particular type but can be used with any type that meets certain requirements. This promotes code reusability and type safety, as the same piece of code can operate on different data types without being rewritten. Functional programming. Functional programming is a paradigm where programs are constructed by applying and composing functions. It emphasizes the use of pure functions, functions without side effects, and avoids changing state or mutable data. This approach leads to more predictable and easier to test code. Functional programming often uses higher-order functions, which are functions that can take other functions as arguments or return them as results. Languages that are known for functional programming include Haskell, Lisp, and Scala, although many modern languages like Python and JavaScript support functional programming features. Now, as an important part of this video, let's talk about the advantages of learning C++. High performance and efficiency. C++ is renowned for its high performance and efficiency, offering fine-grained control over system resources, which is crucial for applications where speed and resource management are critical. This makes C++ the language of choice for system-level programming, where it is extensively used in developing operating systems, game engines, and real-time simulations. Its ability to directly manipulate hardware resources and manage memory effectively ensures optimal performance, making it indispensable in scenarios that demand rigorous resource management and swift execution. Cross-platform development. Portability. One of the most significant advantages of learning C++ is its portability. Code written in C++ can be compiled and executed across different platforms with minimal modification. This capability makes it an ideal choice for developing cross-platform applications. For instance, a software product developed for Windows can be adapted for Linux and macOS environments without extensive rework. This reduces the time and cost associated with developing and maintaining multiple code bases for different platforms, allowing developers to focus on enhancing functionality and performance. Support for various environments. C++ is supported on a wide array of operating systems, including but not limited to Windows, Linux, and macOS. This extensive support ensures that applications written in C++ can be deployed across diverse environments, catering to a broader user base. Developers can leverage platform-specific features while still maintaining a common code base, thanks to the language's flexibility and the availability of cross-platform development tools and libraries. This adaptability is particularly valuable for creating software that needs to operate seamlessly in heterogeneous IT ecosystems. Strong community and ecosystem. Active community. The C++ community is large, vibrant, and highly active, contributing to a rich ecosystem of resources that support developers at all levels. Extensive documentation, forums, online courses, and open-source libraries are readily available, making it easier for newcomers to learn the language and for experienced programmers to refine their skills. This active community engagement ensures that developers can find help and collaborate on projects, fostering a culture of shared knowledge and continuous learning. This collaborative environment is crucial for staying updated with the latest advancements and best practices in C++ programming. Professional opportunities. Mastering C++ can open up numerous professional opportunities across various industries. The language's efficiency and performance make it a preferred choice for high-frequency trading platforms, game development, real-time simulation, and system software, among others. Companies in finance, gaming, aerospace, and technology sectors highly value proficiency in C++, as it is integral to their core systems and applications. Thus, learning C++ can significantly enhance a developer's employability and career prospects, offering roles that are both challenging and rewarding. Foundation for learning other languages. Understanding fundamentals. C++ provides a robust foundation in programming fundamentals, which is essential for any aspiring software developer. The language's complexity and depth cover crucial concepts such as data structures, algorithms, memory management, and object-oriented programming. Understanding these core principles in C++ makes it easier to learn and adapt to other programming languages like Java, C#, or Python. This foundational knowledge ensures that developers can write efficient and effective code in any language, enhancing their versatility and adaptability in the ever-evolving tech landscape. Transferable skills. The skills acquired through learning C++ are highly transferable to other programming languages and domains. Concepts like data structures, algorithms, memory management, and object-oriented design are not unique to C++, they are fundamental to programming in general. Mastery of these concepts in C++ means that developers can apply the same principles when coding in languages like Java, Python, or C#. This transferability broadens a developer's toolkit, allowing them to tackle a wide range of programming challenges and making them more valuable in the job market. C++ is a general-purpose programming language supporting both procedural and object-oriented programming. Source code is the written instructions in a programming language that developers create to tell a computer what to do. So we call the code we write in C++ as C++ source code. And also, the file written in any programming language is called source file. So we call a file written in C++ source file. How can we differentiate a file written in C++? When we write the actual code for our program, we use what's called a source file. These files usually end with .cpp. Think of a source file like a recipe where you write down the steps to make your dish. In a C++ source file, you write down the instructions that the computer will follow to perform tasks, such as adding numbers or displaying messages. Imagine you are making a dish, and you have a list of ingredients you need. In programming, when you want to use certain functionalities, like a function or a class, in multiple parts of your program, you create what's called a header file. Header files usually end with .h or .hpp. These files contain declarations, which are like ingredient lists, telling the program what functions or classes are available and how they work. Other parts of your program can include these header files to know about these functions or classes. While .cpp for source files and .h or .hpp for header files are the most common conventions, you might come across other file extensions too. .cc. This is another extension you might see for C++ source files. It's like an alternative to .cpp. .cxx. Similar to .cc, .cxx is used for C++ source files in some projects. .cp. Occasionally, you might find C++ source files with this extension, though it's not as common. And also, we sometimes need to use libraries in C++ programming. The C++ standard library is like a big collection of tools that come built-in with C++. These tools are ready to use right out of the box, and they help us do common tasks easily, like working with numbers, text, and more. Think of it like a kitchen stocked with all the basic ingredients and utensils you need to cook a meal. The C++ standard library is like having flour, sugar, pots, and pans already in your kitchen. You don't have to go out shopping for these basics, you can just start cooking right away. In C++, the standard library gives us things like ways to work with numbers, organize data, and communicate with the user. It saves us a lot of time and effort because we don't have to write everything from scratch. Instead, we can use these ready-made tools to make our programs faster and easier to create. Sometimes, we need special tools that are not included in the standard set. They are like going to a specialty store to buy exotic spices or unique kitchen gadgets. For example, if you want to bake a fancy cake, you might need a special type of chocolate or a unique baking tool. This is where external libraries come in. For example, if you need to create a game, you might use an external library that provides advanced graphics tools. These libraries are created by other developers and can be added to your project to make it more powerful and versatile. When you write a complete trying to write all the necessary code into a single program and later try to debug or extend later. This kind of approach is doomed to fail and would usually require rewriting from scratch. So in order to tackle this scenario, we can try to divide the problem into multiple subproblems and then try to tackle it one by one. Here, let's assume that I am splitting my program into two parts. Let's name it as part1.cpp and part2.cpp. Now, we need to execute this program. But as we all know, computer can understand only the binary language or the machine language, which consists of only one and zero. So, we need to translate the source code into machine code. For this, an executable file for each source code has to be created. To do this, the build process is really important. It converts source code into an executable program by preprocessing, compiling, assembling, and linking it. Preprocessing. The preprocessing stage in the C++ build process handles directives that begin with hash in the code. This includes several key operations, file inclusion, macro expansion, and conditional compilation. File inclusion is managed by hash include directives, which incorporate the contents of header files directly into the source file, ensuring that all necessary declarations are available. Macro expansion is performed by hash-defined directives, which replace macros with their corresponding code, allowing for code reuse and simplification. Conditional compilation is controlled by directives such as #ifdef, #ifndef, #if, #else, and #endif, which determine whether certain sections of code are included based on specified conditions. It's okay if you do not know about preprocessor directives. I will definitely cover that part in my upcoming video series about C++. The output of this stage is a single, preprocessed source file where all macros have been expanded, and all headers have been included, ready for the next stage of compilation. The .to extension typically refers to a preprocessed C++ source file. It contains the result of the preprocessing stage, with all macros expanded and header files included, but it has not yet been compiled into assembly code. Compilation. After preprocessing, compilation process translates the preprocessed code into assembly language which computer understands better. It carefully to make sure it follows all the grammar rules, syntax checking, and makes sense logically, semantic checking. Then, if we want, it can also try to make our code run faster or take up less space in the computer's memory, optimization. After that, it turns our code into assembly language. Even though there's a lot of compilers, we will use GCC compiler for C++ in this tutorial series. Some compilers directly output the machine code, but here we discussed about the compilers that convert the preprocessed code into assembly code because GCC compiler outputs the assembly code. The assembly file extension commonly used for assembly language source files is .s. But if you have made any mistake, you have to go back to the source code and redo the whole process again. If there is no mistake, then you will get the assembly code. But even now, the computer can't directly understand the assembly code. So, after that, we need to convert these assembly codes into machine codes. For this, we need a language translator program called assembler. It can translate the assembly code to machine code, object code, which can be easily understood by computer. These files containing object code are called object files and they have the extension obj in Windows. But in Linux and macOS the extension is .o. After generating object files during the compilation process, the linking phase is where these files are combined to create the final executable program. For this, a program called linker is used. The linker takes part.obj and part2.obj and the libraries and link them to make a single executable file. Also, there are two types of external libraries called static libraries and dynamic libraries. The main difference between static and dynamic libraries lies in how they are linked with executables and how they impact the size and distribution of the resulting programs. Static libraries are linked at compile time and increase the size of the executable, while dynamic libraries are linked at runtime and reduce the size of the executable but require the presence of the library files on the system where the program is run. So, at that time, if you haven't included the necessary libraries, an error will be generated by the linker. Then you have to recheck and include those libraries and do the whole process again. If the linker can find all the necessary files, it will generate a single executable file. Now, the build process is over. After that, we need a loader to load the executable into the main memory, resolve dynamic library references, and prepare the program for execution at runtime. And then, as the last step of the process, the program is executed to give an output according to the source code we have written. But, luckily, this process does not have to be implemented manually. Imagine if the preprocessor, compiler, and linker were all bundled together in a single package. Wouldn't that be convenient? Absolutely. This package is what we call a toolchain. These tools are linked in a chain, the preprocessor outputs to the compiler outputs to the linker, and finally, the linker produces the X file. Essentially, a toolchain helps translate our human-readable C++ code into machine language. There are several compilers available for C++ programming, such as the GNU C++ compiler, ARM compiler, and Turbo C++ compiler, among others. To write our C++ code, we can use any text editor like Notepad, Notepad++, or Sublime Text. We save our file with a .cpp extension, indicating it's a C++ source file. We then pass this file to our toolchain using a command, and the toolchain handles the rest, producing our final output. Now that you understand toolchains, let's move on to IDEs. When working on large projects with hundreds or even thousands of files, managing them manually can be incredibly time-consuming and cumbersome. This is where an integrated development environment, or IDE, comes in. An IDE offers a suite of tools including a text editor for writing code, a toolchain for compiling, and features like syntax highlighting for C++ keywords, all within one unified environment. This integration makes development faster and more efficient. There are many IDEs available, such as CodeBlocks, NetBeans, and Eclipse. However, I'll use CodeBlocks in my tutorial series. That's all for today. In the next video, I'll show you how to install a toolchain and an IDE on your system. If you have any questions, concerns, or suggestions, please leave a comment below. I'd love to hear from you. If you enjoyed this video, please hit the like button. Don't forget to subscribe to my channel and press the bell icon so you don't miss any future videos. Thanks for watching.